So in class we talked about adding and subtracting polynomials. We're kind of switching gears here really quickly into the laws of exponents and knowing when to multiply two exponents together or when to add two exponents together. So let's go ahead and start on our examples. If you want to take a moment to go ahead and write these two examples down. This is when you add exponents together. You add exponents together, and this is going to sound not right, but you add exponents together when you're multiplying two things. Two terms. That's when you add exponents together. So this first example, I have 2y to the third times 4y to the second. Well, if I just saw 2 times 4, you would just multiply those. So you take your coefficients and you multiply 2 times 4, which gives you 8. And then you add your exponents. You multiply your coefficients, you add your exponents. So then I'm taking y, and then one exponent's 3, and one exponent is 2. So the final answer for this would be 8y to the fifth. I was multiplying two things together, so I added my exponents. Same thing here. They're both in parentheses, but I'm still going to be multiplying those two things together. So you multiply your coefficients, which gives you 21, and then you're adding your exponents. So you have z, and my exponents are 3 and n, so I'm taking 3 plus n. That's a totally fine way to write it. There's no other way to show that you're adding when it's a number and a letter together. So 21z, and then I'm just going to flip the order because I like to write my variables first. But that's literally your answer. 21z and then n plus 3 because I'm adding my exponents together. When it's a multiplication problem, you add. When it's a multiplication problem, you add. Okay? Take a moment to write these two guys down. So this is talking about when we multiply exponents. With this, I'm not multiplying two things together. There's only one term here. The only difference is this one term is being taken to an exponent. This one term over here is being taken to an exponent. When that happens, that's when you multiply your exponents together. So, the first thing we have to do is I like to distribute my exponent to all the things on the inside. There's a big coefficient, and then I see 3 letters. So coefficient, and 2 letters, my bad. So I'm taking 2 to the third power. I'm taking a to the 2 times 3. And I'm taking b to the 5 times 3. I'm multiplying my exponents. So 2 to the third power gives me 8. We're going to have a to the 2 times 3 is 6, and b 5 times 3 is 15. And that's just how you would do that one. So with this, you don't multiply your coefficients together. You actually take the coefficient to whatever power is happening, and then you multiply your other exponents. Let's do the same thing over here. I'm taking this n, and I see 2 variables inside my parentheses, a y and a z. So what I'm doing is I have y to the a, and I'll be multiplying that by the exponent n. And then I have z to the third, and I'll also be multiplying by that to the exponent of n. How you show multiplication is you just write the two things next to each other. We have a times n, which is just an, and then 3 times n, which is just 3n. And that's how this one ends up. Again, I'm just multiplying my exponents, whether they're letters or numbers or whatever, you're just multiplying. So you multiply when the exponent's out here. You add the exponents if it's 2 terms written next to each other and you're multiplying. Let's kind of put it all together, what we were doing. So these look very, very complicated. Take a moment to write them down. But again, I want you to think about, am I multiplying 2 terms together, or is one term being taken to a power? Okay? With this example, I see that I'm multiplying two terms together. When you're multiplying two terms together, that means we are adding our exponents. Okay? The first thing, however, I want to do is, this is a multiplication problem, so you multiply your big numbers, you multiply your coefficients. 2 times 3 gives me 6. I now have, both of these have the variable a, so I'm dealing with that. And remember, you're adding your exponents. So one exponent is n minus 1, and I'm adding to it the exponent n plus 1. Now we're going to look at this. What of this can we combine? Well, I have some n's, and I have some 1's. Those are what I can combine. So I still have 6a. I have an n plus an n, which means I have two n's now. And negative 1 plus 1 means they're gone. So this one just ends up being 6a to the 2n. I know it's more complicated because your your exponents are so unusual, but just keep in mind, if you're multiplying two things together, you're adding your exponents. Just keep that in the back of your head. This problem over here, this we're actually going to do both of the rules, because I see that, yes, I'm multiplying two terms together, but one of my terms is being taken to an exponent. And that's what I have to do first. Remember, when your term's being taken to an exponent, you're going to be multiplying your exponents together. So I'm just going to write 2x to the 4th, so it's there. With this one, I'm taking the 3, and I'm taking it to the second power. I'm also taking x, and then k minus 2. But I'm taking that to the second power, which means I'm multiplying. I still have 2x to the 4th. My 3 becomes a 9. And x becomes, I'm distributing the 2 to both of these things. So I end up with 2k minus 4. Now I have two things that are being multiplied together, which means I'm going to be adding my exponents together. First, you have to multiply your coefficients. 2 times 9 gives me 18. And then I have these variables. They're both x, which means their exponents are going to be added together. So one has an exponent of 4, and I'm going to add to it the other exponent, which is 2k minus 4. Well, these 4's can be combined. One's positive, one's negative, so they're going to cancel. And this ends up being 18x to the 2k. So this one, not only did we have to use the multiplication, we had to use the addition. So tomorrow when you come to class, you get to use your notes, but you're going to do a try on your own to kind of see how you did and how you understand this unit so far.